Hello, my name is Francisca Durán. I'm an undergraduate student from Pontificia Universidad Católica de Chile, and my poster presentation is called Binding Free Energy Prediction of Novel Compounds with Aryl piperazine peptide structure as Potential Inhibitors of Factor Xa. Cardiovascular disease are the #1 cause of death globally. Thrombosis is a pathology that can cause stroke, acute coronary syndrome, and venous thromboembolism. Factor Xa is a serine protease that plays a key role in the clotting cascade by activating prothrombin to thrombin. Direct factor Xa inhibition has been proved as successful anticoagulation therapy. Nevertheless, approved factor Xa inhibitors like rivaroxaban and apixaban have adverse effects, where the risk of bleeding the major concern. Consequently, there is a need to develop new small molecules that can inhibit factor Xa. Here we show novel compounds with aryl piperazine peptide structure as potential factor Xa inhibitors. A virtual combinatorial library of 96 compounds with aryl piperazine scaffold was generated, and their binding conformations to factor Xa estimated by molecular docking, followed by binding free energy prediction through the molecular mechanics Poisson-Boltzmann surface area method. Relative binding free energy calculation without entropy contributions were performed, and multivariate analysis of variance suggests a preference for chlorobenzene at the S1 site, and also a preference for large aliphatic amino acids like isoleucine and leucine binding to a site lined by residues glutamine 192, arginine 143, and glutamic acid 147. The binding mode of this compound is in L shape within the active site of factor Xa, similar to rivaroxaban and apixaban. The predicted Ki values for these ligands are in the subnanomolar to nanomolar range, based on a calibration curve generated from binding free energy estimates of known factor Xa inhibitors. So as conclusions, these results suggest potential factor Xa inhibition of aryl piperazine peptide derivatives and are the first step for the further synthesis and biological validation.